Hey guys, you are having trouble with this topic 7 mid-topic assessment. So there's going to be a couple things. Number one, I'm going to go through it here in this video. I'm going to go through each question and it'll be available to you once you've taken the mid-topic assessment. The second thing that I'm going to do is I'm going to remove the must get a 2.5 on the mid-topic assessment and take that out of the grades counted in Sapphire. It's just causing a lot of you that are pretty comfortable with material, you're not doing as well on this, and then it's kind of pausing your progress. So once you take it, I'll just put it as that it has to be completed. Then you can watch this video and you can look at the mistakes or the ones that you got wrong. And then you're free to ask me questions if you want more clarification. But if this video clears it up for you, then you can move on. And I'm going to take it out. It will be posted in Canvas as a grade, but it won't move over to Sapphire like your other assessments do. So we're going to start with number one. Number one, it says, how is a rhombus related to a parallelogram? How does finding the area of a rhombus compare to finding the area of a parallelogram? Select all that are true. So for this particular one, there are three that are true. So the first thing you need to know is, what is a rhombus? So a rhombus is a parallelogram, but the sides are slanted. It kind of looks like a diamond. So there's four sides. These are equal. We find the area the same way we find the area of a parallelogram. So if you think about like a square, then kind of shift it a little to make it a diagonal, that is what a rhombus is. So a rhombus is a parallelogram with equal sides. Yes, a rhombus is found, the area of a rhombus is found using area equals base times height. Yes, and the area is found the same way for a rhombus and a parallelogram. So those are the three that is true. A parallelogram is not always a rhombus. There are parallelograms that are not a rhombus. They don't have four equal sides. And the area of a rhombus is less than the area of a parallelogram with equal dimensions. Doesn't make sense because we find the area of a rhombus and a parallelogram the same size, the same way. So if their sides are equal to the same, you're going to get the same area. Okay, let's take a look at number two. I'm going to say that the one that was tricky on this one for most of you was the trapezoid one. So if we look at the area of the triangle is 34 feet squared. Here's my triangle. Area of a triangle is 1/2 base times height. So now I look at my triangle. Area is 1/2. The base is 10. The height is 6.8. So we can do 10 times 6.8 gives us 68. When we multiply 1/2 times 68, we get 34 feet squared. So the answer to the first one is true. Okay. Now I want to go to the area of the parallelogram is 56. Which is the parallelogram? Well, the parallelogram is this four-sided figure right here. Let me pick a different color. We'll do green. Area of a parallelogram is base times height. My base is 9. My height is 7. The height makes a right angle. 9 times 7 equals 63 centimeters squared. So that one is false. Now we can look at the area of the trapezoid. Let me change colors. Here's our trapezoid. The area of a trapezoid is 1/2 times the height times B1 plus B2. So if I plug in the numbers for my trapezoid, I have 1/2. The height is 3. I have to add my bases together, 7 and 9, which is 16. So 3 times 16 is 48. And when I take half of 48, I get 24 inches squared, which makes the third one true. Okay, I think that some of you got confused with this one, just not remembering what a rhombus is. So I told you in the first slide that the rhombus is, there. The rhombus is it's a square. It's a four-sided, it's a parallelogram, and shifted, kind of like a diamond. So if we say that the height is 3, that's just this line right down here. 3, that's not the best drawing, but it'll work. And then 6.5 is base. So we take 3 times 6.5. 3 times 6.5, and that gives us 19.5. So when we entered 19.5. One of the problems also is sometimes numbers pop up when you go to click in that blank. That is your computer trying to autofill. It is not choices. It is not a drop-down menu. This is a blank, and your computer's like, oh, you've typed these other numbers before. Maybe you want to use one of them. So I think that also was a little bit confusing on your computer. You saw numbers pop up when I typed, but 19.5 is correct. Okay, so for this one, we have a window, and this window is a kite. So I'm going to show you 2 ways to find the area of the kite. So way 1 is, this is my favorite, it's 1/2 diagonal 1 times diagonal 2. Now, where that gets tricky is identifying the diagonals. So this is a diagonal, this whole thing, and that's a diagonal. So if we go back to our formula and we have area equals 1/2, the diagonal 1 is 4 plus 3.2, which is 7.2, times diagonal 2 is 2 plus 2, which is 4. So we can type in 7.2 times 4 divided by 2 is 14.4 feet squared. So the other way that we can find the area of a kite is, I'm going to clear my screen, start again, is we can make these into triangles. And then we have a triangle that is here, and we have an identical triangle that is over here. So we're going to find the area of one, and we can double it. The area of a triangle is 1/2 base times height. So the area is 1/2. My base is 4 plus 3.2, so 7.2. The height is 2. So if I take 7.2 times 2, I get 14.4. Now, I'm going to take half of that to get the area of it, but then I'm going to times it by 2 because there's 2 of them. So I'll go ahead and go through each step. Divided by 2 is 7.2. So the area of 1 is 7.2. In order to get this whole thing, I need to double it, which is back to 14.4 feet squared for the entire rhombus. All right, so this one we are going to look at a trapezoid within a trapezoid, and we want to know the area of the shaded region. So we need to find the whole area, and then we need to subtract the area of the missing piece in the middle. Again, I think that most of the problems with this one were finding the area of a trapezoid, which I also sent you guys a video the other day to remind you. 1/2 times the height, B1 plus B2. I'm going to find the entire area first, then I'll find the area of the smaller and subtract it. So I'm going to go ahead and bring down the 1/2. My height, I just have to count. I'm at 8 down to 2, so that's 6. My B1 goes from 4 to 6, so that's 2 plus my bottom one is from 2 over to 8, so that's 6. So the area of the overall trapezoid, if I don't take out that middle part, is 1/2 times 6 times 8. You could do this however you want. I like to take half of 6, which is 3. 8 times 3 is 24. So 24 units squared is the outer trapezoid. I'm going to go here to my drop downs. Find the area of the outer trapezoid and then subtract the area of the inner. The area of the outer trapezoid is equal to, I got 24 square units, the area of the inner trapezoid. So now I'm going to find this inner one. I'm going to use my same formula, which is right here. So I'm going to say area equals 1/2. My height of my inner is, it goes from 3 to 6, so it's 3. And then my base 1 is just 2 plus 4, which is 6. I can write it up here, 2 plus 4, which is 6. So I'm going to say area equals 6 times 3 is 18. Half of that is 9. So I'll come back here and say the inner trapezoid is 9. So the area of the shaded region is equal to, I have to take 24 minus 9, which is 15. So the whole area should be 15 square units. So you can see that that is all the correct answers for the mid-topic assessment. If you are still confused about something, you may definitely reach out. I can look at it with you. I can go over it. And again, I'm going to take out the restriction that you have to get a 2.5 and remove it from being synced with Sapphire. All right. See you soon.